Our next speaker suffered from sinusitis and allergies-related respiratory problems from a young age. So many of her childhood memories involve being in a hospital and seeing her parents worry about her. And so I guess it's not surprising that she is now part of a project that's related to respiratory disease. She's passionate about microbiology and pathology and was adamant to pursue a career related to her degree. She feels privileged to be doing just that and rising above the social pressures in her home country to do so. Please welcome, from the Faculty of Education, Science, Technology and Maths, Cynthia Mathew.
Today, as of right now, there's 1 billion people in the world suffering from asthma, bronchitis, and pneumonia. And I bring before you the criminal masterminds behind their suffering. These viruses cause permanent lung damage, and that puts us at risk to develop long-term breathing problems. And for now, as of now, we're not doing much. We're so focused on trying to relieve the symptoms that we haven't found a cure in actually stopping these criminals from causing more damage. But there's hope at the end. The thing is, we spend nearly $28 billion in trying to find medicines or even treat and undergo hospitalization just against these viruses. So my work is looking into applying a group of nuclear export inhibitors against these viruses. Because even though they're all from different backgrounds, they all look and work differently, they cause disease differently, they can't help themselves from behaving the same way, which is they're all hijackers. What they do is that they penetrate into our lungs and take over the functioning of our cells. They attack the nucleus in particular. Why? Because the nucleus is our command center. It's the brain of the cell. If a cell has to do or function in any way, the nucleus has to give the right signal. So these viruses target in overtaking the nucleus to make more copies of itself and then spread into neighboring cells. The use of nuclear export inhibitors would mean that these viruses won't be given a chance to come out of the nucleus and finish their infection cycle. Now, this principle has already worked in the influenza virus, which is the main criminal on the list. My work is focused on the second person on the list, the respiratory syncytial virus. This little monster is responsible for hospitalization of nearly 50,000 infants or children below the age of 2. Stopping the virus, my work is focused on finding an in vitro method to study the differences in how these drugs work in a normal cell and in a virus-infected cell so that we can find a strategy that is suitable for infants and children below the age of 2. And in short, what I'm looking at is trying to find a strategy that will be able to hijack the hijacker, foil his plans, and in turn, help in relieving the suffering of nearly 1 billion people, or at least a billion people in the future. Thank you.